Ever wondered how Kubernetes manages to handle your applications so effectively? Well, wonder no more. Kubernetes is the heartbeat of modern application management. It's the orchestrator that ensures your applications are running smoothly, scaling efficiently, and recovering swiftly from any hiccups. Today, we're going to explore the magic behind it all, breaking down the intricate architecture of Kubernetes and showing you just why it's so essential in today's tech landscape. So get ready to dive into the fascinating world of Kubernetes architecture. Kubernetes at its core is a container orchestration tool. It's a powerful system designed to manage and coordinate containerized applications across multiple machines. But what does this mean, and how does it work? Let's delve into the architecture of Kubernetes and explore its master components. First, we need to understand what a container orchestration tool does. Imagine having hundreds, even thousands of containers, each running a piece of your application. Manually managing these containers would be a daunting task. That's where Kubernetes steps in. It automates the deployment, scaling, and management of containerized applications, effectively taking the burden off your shoulders. Now let's talk about Kubernetes architecture. It operates in a master worker layout where the master node controls and coordinates the worker nodes, which are the machines running your applications. Let's start with the master components. There are 4 key components in the master node that orchestrate all the operations. First up is the API server. It serves as the front end of the Kubernetes control panel. It's the component through which all other components communicate and enforce the desired state of the application. Next is etcd, a distributed reliable key-value store that stores the configuration data of the Kubernetes cluster, providing a way to store critical data in a distributed network. The scheduler, as its name suggests, schedules tasks. It determines which worker node and unscheduled pod, the smallest and simplest unit in the Kubernetes object model, should run on based on resource availability. Lastly, we have the controller manager. It's a daemon that embeds the core control loops, which are a non-terminating loop that regulates the state of the system. The controller manager maintains the desired state of the cluster and performs routine tasks to keep the system in balance. These master components make sure your applications run smoothly, but there's more to this. In the next scene, we'll dive deeper into worker nodes and how they interact with the master components, so stay tuned. Now that we've covered the master components, let's move on to the worker nodes. Worker nodes, also known as minions, are where the magic happens. They are the machines that run your applications and cloud workloads. Each worker node contains all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. Let's delve a little deeper. Within each worker node, we find what we call pods. Pods are the smallest deployable units of computing that you can create and manage in Kubernetes. They can contain one or many containers, depending on your application's needs. Containers within a pod share an IP address and port space and can communicate with one another using localhost. Next up, we have services. Services are an abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to worry about networking. The platform takes care of assigning an available IP to your service if you need it. And finally, we have volumes. A volume is essentially a directory, possibly with some data in it, which is accessible to the containers in a pod. It's a mechanism for decoupling the storage from the lifecycle of a pod, which makes the data persistent across container restarts. So, how do these components interact? Well, when an application is deployed, the master node schedules the pods onto the worker nodes. Each pod communicates with the service through the IP address, and the service then routes the traffic to the appropriate pod. The volume, on the other hand, provides the shared storage for the containers within the pod. These worker nodes and the components within them are what really carry out the tasks. They do the heavy lifting, while the master components provide the orchestration. It's a harmonious dance, a testament to the power of distributed computing. So, we've unraveled the Kubernetes architecture, but let's summarize it. Kubernetes is a complex system, but at its core, it's all about orchestrating and managing containers. The architecture is built on a cluster, which is a set of machines or nodes. The master components are the brains of the operation. They make global decisions about the cluster and detect and respond to cluster events. The master components include the Kube API server, which exposes the Kubernetes API, the control plane's interface. The etcd is the consistent and highly available key-value store where all cluster data is stored. The kube scheduler watches for new work and assigns it to nodes. The kube controller manager runs the core control loops, repairing the state of the cluster, and the cloud controller manager integrates the cluster with the cloud provider's API. The worker nodes are where the magic happens. They run the applications and workloads. Each node contains a kubele, which communicates with the master components, a container runtime, like Docker, to run the containers, and a kube proxy to handle network routing. When a task is executed, the master schedules the work to a node. The kubele on the node starts the container, and the application runs. The beauty of Kubernetes lies in its automation and scalability. It automatically manages, scales, and maintains your applications, saving time and resources. And that, in a nutshell, is how Kubernetes works to manage your applications. Kubernetes is undoubtedly a powerful tool for managing applications. Its architecture, ingeniously designed, is what makes it such a game changer. Taking the time to understand its intricacies can open new avenues for efficiency and reliability in your IT projects. Its components, from pods to services, from nodes to clusters, all work in harmony to ensure your applications are running smoothly and are easily scalable. This architecture is the backbone of the Kubernetes system, making it an essential topic for IT professionals to delve into. Moreover, Kubernetes isn't just about understanding its architecture. It's about embracing a new way of managing applications, a way that's dynamic, resilient, and scalable. It's about learning to navigate the sea of containers with a reliable compass. So keep exploring, and you'll find Kubernetes to be an invaluable ally in your IT